section 3.3, we want to talk about some other identities or formulas about the double angles, half angles, and the reduction formulas. In previous sections of chapter 3, 3.1, and 3.2, we learned about some fundamental identities in trigonometry. We also learned about the sum and difference identities, and in this section, we want to learn about some other identities like double angle formulas. The double angle formulas are for the angles that are in double. For example, if we have angle theta, double angle is when we want to find the sine, cosine, and tangent of two theta. And these are all the formulas that we have for double angles. And all of these formulas are coming from coming from the previous formulas that we learned, but the proof of all of these formulas is in the textbook. But something that is important in this class is that we know the formula and we know where to use them. For example, I just want to give you an example. To find the sine of 2 theta, instead of 2 theta, we can use theta plus theta, because 1 theta plus another theta is 2 theta. And then, based on what we learned in section 3.2 about sum formulas, we can have the formula for the sum of the two angles, which is the sine of the first angle times cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And as you see, we have one sine times cosine, another sine times cosine, and if we add them together, we will end up to 2 sine times cosine. So all of these formulas can be found by using the other identities. For the sine of two double angles, we only have one formula, which is 2 times sine of theta cosine of theta. For tangent, we also have one formula, which is the fraction of 2 tangent of theta on the numerator and 1 minus tangent square on the denominator. But for cosine, we can have actually 3 formulas, because the actual formula for the cosine of double angle is cosine square minus sine square. But in the fundamental identities, we learned that the sine square plus cosine square is always equal to 1, which means the sine square is always 1 minus cosine square. And if you replace the sine square by 1 minus cosine square, and then distribute the negative, and then add or subtract by the cosine square, you will get 2 cosine square minus 1. We also know that the cosine square is 1 minus sine square, which means that if I replace the cosine square by 1 minus sine square, and bring down the negative sine square, and then combine the like terms, I would get 1 minus 2 sine square. So when you are using a formula, when you want to use a formula for cosine of 2 theta or the cosine of a double angle, you can use either of these 3 formulas based on which one works better. Sometimes for verifying some identity, we only need cosines, so it's better to use the second one. Sometimes we only need sines, so it's better to use the third one. Sometimes if we use the first one, that helps, based on the rest of the problem. So you can use either of these formulas. Okay. For example, we have the first example says if sine of theta is 4/5 and theta is an angle in quadrant 2, find the exact value of sine of 2 theta and the cosine of 2 theta. Okay. To find the sine of 2 theta, if I want to use the formula, I need 2 times sine of theta times cosine of theta, which means I need the cosine of theta, and I need to find that first. How can I find the cosine from sine? Again, we have different techniques to find that. We can use trig identities, or we can use the right triangle properties, because if you use the right triangle properties, you know that the sine is always opposite over hypotenuse. Then you can use the Pythagorean theorem to find adjacent, and then cosine is adjacent over hypotenuse. And after having both of the sine and cosine, now it's easy to find the sine of 2 theta, because I know the sine of 2 theta, it's 2 times the sine of theta cosine of theta. And if I replace the numbers for sine and cosine, I would get negative 24 over 25 for the sine of 2 theta. To find the cosine of 2 theta, we have 3 different formulas. We can use either of them. It doesn't matter which one you use. You still get the same answer. You can use the first formula, cosine square minus sine square, because you have both of the cosine and sine. You can use 1 minus 2 sine square, or you can use 2 cosine square minus 1. And the answer is negative 7 over 25. Next example, they're asking to find the exact value of cosine square of 15 minus sine square of 15. Okay, I have no idea what's the cosine of 15 or the sine of 15 degree. But I know that I have formula for the cosine of 2 theta, which is cosine square minus sine square. So from now on, every time you see cosine square minus sine square of the same angle, remember that that expression can be equal to the cosine of the double angle. And this expression can be equal to the cosine of the double angle, and the angle is 15 degrees. And the double of 15 is 2 times 15 is 30 degree angle. Now, what's the cosine of 30 degree angle? It's just root 3 over 2. That's it. Sometimes you may have this part, the left side of the identity, and you may need it to rewrite the as a an expanded form and rewrite the right side for that. Sometimes they may give you the right side, and it's better or easier if you to just convert it to the double angle and then use that to find answer. Next example, we want to verify the identity. Okay, so to verify the identities, you know that you always have to start from one side and then replace identities, simplify to get the other side. Or if one side by itself cannot help you to get the answer, you can work on both sides and get the same things from the both sides. We always start from the most complicated one. It doesn't matter if it's the right or left. So right now you may say, okay, we have more function on the right side, so it's better to start from the right. But I want to tell you, anytime you see a sine or cosine of sum or difference between angles, or the sine cosine of the double angles, like sine of 2 theta, cosine of 2 theta, sine of 3 theta, cosine of 3 theta, you always start with that side. In this case, I want to start from the left side, which is the sine of 3 theta. I don't know what's the, it's actually a triple angle, and I have no idea what's the sine of 3 theta, but I know that the 3 theta, it's 2 theta plus 1 theta. And I can rewrite this one as a sine of 2 theta plus theta. And now I have a sum of 2 angles, and I can use the formula for the sum of 2 angles, which is the sine of first angle times the cosine of the second angle, plus cosine of the first angle times the sine of the second angle. Now, we see double angles here. We can replace formulas for double angles. What's the sine of 2 theta? Is 2 sine of theta cosine of theta. So we replace these for the sine of 2 theta, bring down the cosine, and we replace this one for the cosine of 2 theta and bring down the sign. Why we need to use this one? Because for cosine of 2 theta, we have 3 different formulas. I told you, you can use either of them based on which one works better. Since the right side of my identity is all sine, so I'm going to use the formula for cosine of 2 theta, which only included sine. Because if I use the other formulas, which has the cosine, I have more step to to change them to sine. So I just added more steps to my work. So I'm going to use the formula with the sine to skip those steps. Then we need to multiply. Multiply these. So I have cosine times cosine, which is cosine s squared. And for this part, I need to distribute by the sine. And we got this one. Now let's see what we can do. Since the right side of the identity, it's all sine, I need to change cosine squared to sine as well. So what we can replace for cosine squared to change it to sine, and the only formula that we have is that cosine squared is always 1 minus sine squared. So we replace 1 minus sine squared for the cosine. Then we need to distribute again 2 sine theta times 1, which is 2 sine theta, 2 sine theta times sine squared, which is 2 sine cubed theta, is this part. This part is repeating actually. So you can see the answers here. And now we can combine like terms because sine theta and sine theta are like terms, and we can add them together. 2 sine theta plus 1 sine theta is 3 sine theta. And these two are also like terms because both of them have sine cubed, and negative 2 sine cubed by negative 2 sine cubed is negative 4 sine cubed. And the answer is negative 4 sine cubed. And you see that's exactly the right side of the equation. And we are done. Next example, we want to verify this identity. Okay, let's see what we can do. We have sine of 4t on the left side and another expression based on the sine and cosine of t on the right side. Again, since I have a sine of this angle, 4t, instead of just having a sine of t, I'm going to start from the left side. So what is the sine of 4t? What we can write instead of 4t? I know that the 4t is 2t plus 2t. Now I have two angles, and the sum of two angles have a formula. And this, for the sine of sum of two angles, we have the sine of first angle times cosine of the second angle plus cosine of the second angle times sine of the first angle. Now all of my angles are 2t, are double angles, and I can replace formulas. The only formula that we have for the sine of 2t is 2 sine cosine, 2 sine t cosine t. What formula we can replace for cosine of 2t? We can use either of those three formulas, and again for this part, we just have 2 sine t cosine t. So we can use 2 cosine squared minus 1, or we can use 1 minus 2 and sine squared. But when I look at the right side of my identity, I see that the first term has 1 sine with 3 cosines. You see? So this side has to have only 1 sine with 3 cosines. So it's better to use the one that includes cosine. But my second term has 3 sines with 1 cosine. So I'm going to use the formula for this one that includes more sine, which is 1 minus 2 sine squared. And now we need to distribute to remove the parenthesis. Distribute, what is 2 sine t cosine t times 2 cosine squared? 2 times 2 is 4 sine t. 1 cosine times 2 cosine is 3 cosines. 2 sine t cosine t times -1, which is -2 sine t cosine t. Distribute this one as well. So 1 times 2 sine t cosine t again is 2 sine t cosine t. And -2 sine squared times 2 sine t cosine t is -4. Sine squared times sine is sine cubed and cosine t. Now when we look at these, we can combine like terms. These two are like terms because they have the same sine t cosine t, but since the numbers are +2 and -2, they actually cancel each other because 2 minus 2 is 0. And the only thing that's left for me is 4 sine t cosine cube t minus 4 sine cube t cosine t, which is exactly my right side of the identity. So what are the power reducing formula? The power reducing formula are the formula that you can use if you want to get rid of the powers. If you want to get rid of the exponent, the s square on top of the sine and cosine, you can use these formulas. And these formulas exactly come from the previous formula that we learned. So you know that the cosine of 2t, you learn that the cosine of double angle is 1 minus 2 sine square. Now, if you isolate the sine square by subtracting 1 from the both sides, and then divided by -2, so you will see that the sine square is 1 minus cosine of 2t, because we have a negative for the denominator, divided by 2, which is that exactly this one. So all of these formulas are also the same formula that we use for double angles, but we are just using in another way. Okay, so if you have sine square or cosine square and you want to get rid of the power, that's one way that we can use. We can use either of these formulas. For example, we have a question. It says, write an equivalent expression for sine to the 4th power that does not contain powers of any trigonometric function. So what we can do for that, so the sine to the 4th power, so for sure, these formulas are for the sine square and cosine square, not for the 4th power. If you have sine to the 4th power, so it's better to rewrite this one as a sine square with another square. Because you know, when one base has 2 powers, the powers get multiplied and you will have sine to the 4th power. But instead of writing sine to the 4th power, I can write sine square with another square, because that helps me to replace something for the sine square. Okay, so now I have a formula for sine square. I can replace the formula and then s square that. If you want to s square this one, you need to square the numerator and square the denominator. If you square the numerator, you have 1 minus cosine of 2x. And you need to square it. For squaring any parenthesis, you need to multiply it by itself. So you will need to write 1 minus cosine 2x and times by another 1 minus cosine 2x. And then do the FOIL, multiply everything out, and you will have 1 minus 2 cosine 2x plus cosine of s squared of 2x over 4. And since you have one single term on the denominator, you can keep that one under each terms of the numerator and write it as a separate fraction. So you have 1 over 4, you have negative 2 over 4, which is negative 1/2, and you have cosine square over 4, which is this one. But we want to have an expression without having any power. We still have second degree here. So what we can do, we need to replace something for that. So we have a cosine square, and the formula for the cosine square is this one. We can replace this formula for the cosine square. But if you look at the formula, you see the cosine square of an angle is 1 plus cosine of the double angle here. But if you have a cosine square of 2x, so the formula that you can replace is 1 plus cosine of the double angle, and the double of 2x is 4x. So make sure to put the correct angle. Okay, so we replace the cosine of 2 of 2x, which is 4x there. And then we need to multiply them. Multiply 1/4 by 2, which is 1/8. 1 plus cosine of 4x. Distribute 1/8. And then combine the like term. 1/4 and 1/8 are like terms. If you add them together, you get 3/8. And then bring down the rest of the problem, because there is no more power on any terms of this expression. And our goal was just writing an expression without having any power, and we are done now. Another example, it says, write an equivalent expression for sine square cosine square that does not contain any powers again. So for sine square and cosine square, we have formulas, so we can replace them. For sine square, we can replace, so sine square x times cosine square. We have one formula for the sine square, which is 1 minus cosine of 2x, double angle, over 2. For cosine square, we have a formula of 1 plus cosine of 2x over 2. There's a multiplication, so I need to multiply the fractions. Multiply the fraction means multiply the numerators and multiply the denominators. If I multiply the denominator, 2 times 2 is 4. And if I multiply the numerators, I need to do the FOIL. 1 times 1 is 1. 1 times cosine 2x. Negative cosine of 2x times 1. And negative cosine of 2x times positive cosine of 2x, which is cosine square of 2x. These two are like term and can cancel each other. So I have 1 minus cosine square of 2x over 4. But I still have a power. I still have a cosine square. I want an expression without having any powers. So I need to replace something. If I want to replace something for cosine square of 2x, I have to replace 1 minus cosine of double angle of that. And since the angle for this one is 2x, the double angle is 4x. So I'm going to replace 1 minus cosine of 4x divided by 2 instead of cosine square of 2x. Okay. So we have one single term here. Let's just separate the fraction to make it easier. So we have 1/4 minus and we can multiply these two. We get 1 minus cosine of 4x over 8. One single term on the denominator, we can separate the fraction again, but don't forget 1/4 still isn't the first term. And we have a negative here and a negative here, which is, oh, I think I forgot that the cosine square is 1 plus, sorry. That should be 1 plus. So there is no more negative. So negative times positive is negative. Okay. Combine the like term, 1/4 minus 1/8, which is 1/8, and bring down 1/8 the cosine of 4x. Now it's done. We have an expression, an equivalent expression to the sine square times cosine square, which has no powers, more than 1. And the other sets of formula are called the half-angle formulas. Half-angle formulas, again, are coming by the previous formula, but just written in different form. So if you remember the double angles, for the double angle, you said that, sorry, the power reducing formula, you learned that the sine square is 1 minus cosine of 2 theta over 2. Now, if this angle is theta, this one is the double angle. If I half this angle and instead of theta, I put theta over 2, so the other angle must be in half, and the half of 2 theta is just theta. And if I want to find the sine, I can take the square root from the both sides. And that's why we have these formulas. This is how you can find the formula. Each of these formulas coming from the previous one, but just written in different forms. But if you see we have a plus and minus in the formula, that doesn't mean that you have to keep both of the plus and minus. One of them only works in the problem. It depends where the angle lies. So based on the quadrant which the half angle lies. So make sure to check where is the half angle, which quadrant the half angle is, and if the sign is positive on that quadrant, you just keep the positive. If it's negative, just keep the negative. And the same for cosine and tangent. And these formula also coming by the mixing of the other formulas as well. So for tangent of half angle, you can use either of these formula, this one or this one or this one, based on which one works better in your problem. For example, we have the cosine of 210, which is negative root 3 over 2, and they are asking us to find the cosine of 105. Okay, I know that the cosine of 210, but I have no idea what's the cosine of 105. But something that I know is the 105 is exactly half of the 210. So it means that I can use half angle formulas. And if I want to use half angle formulas for the cosine, that's my formula. 1 plus cosine divided by 2. So cosine of half angle, it's plus or minus 1 plus cosine over 2. And if this is 105, that means it's half of 210, so this is 210. Okay. We know the cosine of 210. We can replace it with negative root 3 over 2. But which one of plus and minus work based on where the half angle is? My half angle, or 105, is in the quadrant 2, because 105 is an angle in the second quadrant. And in the second quadrant, the cosine is negative. That's why we only keep the negatives, not the plus and minus. We just put the negative, the minus. And if I replace the negative root 3 over 2 for that number, we get 1 plus negative root 3 over 2 divided by 2. Now the question is how we can simplify this one. So one way to simplify this fraction is, since we have a denominator on the top, so to get rid of this denominator, multiply everything on the top by 2. And since we're multiplying the top by 2, we need to do the same for the bottom. So multiply the bottom by 2 as well. So if you multiply the top and the bottom by 2, so 2 times 1 is 2, and 2 and 2 for this one cancel each other, so you only have root 3. And for the denominator, 2 times 2 is 4. But this whole thing is under a big radical. The numerator cannot be simplified anymore because one of them has a radical, one of them doesn't, so they are not like terms. You cannot add or subtract them, so you have to just keep it the same under the radical. But the denominator is 4, which you can bring it out as a 2. And that's your final answer. And the next example, it says we have the cosine of 315, which is root 2 over 2, and we want to find the tangent of 157.5. Okay. We have a cosine, we want to find the tangent. And we know that 157.5 it's exactly half of the 315. So we can use half angle formulas. And the half angle formulas for tangent, we have 3 different formulas for half angle, the tangent of half angle. Which one is easier to use for me? If I want to use this one, I need to have both of the sine and cosine. If I want to use the same, I need both of the sine and cosine. But if I want to use this one, I only need the cosine. And the problem only gave us the cosine. So it's better to use this formula in this case because it's easier. We don't need to find the sine. We don't need to have more work to do. Okay, so let's use the formula. And the formula tells me that the tangent of a half angle is plus or minus of 1 minus cosine of the full angle, 1 plus cosine of the full angle, which means the tangent of 157.5, which is half of the 315, is 1 minus cosine of 315 over 1 plus cosine of 315. But the question is plus or minus before the radical, which one works here? It depends where the half angle lies. The half angle is 157.5, and 157.5 is an angle in the second quadrant. In the second quadrant, the tangent is negative because the sine is positive, cosine is negative, and positive times negative is negative. So I need to keep a negative here instead of plus and minus. Now I'm going to replace the numbers. 1 minus root 2 over 2, 1 plus root 2 over 2. To simplify this expression, it's easier to multiply both of the top and the bottom by a 2, because if you do the same thing on top and the bottom, it's okay, because actually you're not changing anything. So if you multiply by 2, you need to distribute the 2. And if you distribute the 2, 2 times 1 is 2, but 2 times the fraction, 2 and 2 cancel each other, and you only have root 2, and you only have root 2 on the bottom as well. Okay. Right now, this is my final answer, but I see that there is a radical. Still, I have a radical for the denominator. If I want to keep it as a 2 separate radical, I will have this one, root 2 minus root 2 and root 2 plus root 2 with a negative outside. You know that we never leave any fraction with the radical on the denominator. So we need to rationalize that. To rationalize this one, first of all, I see one radical on the whole denominator. If you have only one radical, to rationalize, you just multiply by the same whole radical. And that helps you to get rid of the big radical, and you only have 2 plus root 2 on the bottom without the big radical on top of that. And for the numerator, I can multiply 2 minus root 2 by 2 plus root 2 under a big radical. And if I multiply them, 2 times 2 is 4. Let me do it over here. 2 times root 2 is 2 root 2. Negative root 2 times 2. And negative root 2 times positive root 2, which is just 2. These two cancel each other because they are the same with the negative and positive, and 4 minus 2 is just 2. But I still see a radical on the denominator. So what else we can do to get rid of this radical? Now, since we have two terms on the denominator, if you want to rationalize with when you have two terms, you need to multiply by the conjugate. And the conjugate for 2 plus root 2 is 2 minus root 2. Let me fix this one because there is only a small radical right now. Okay. If I multiply the denominators, since they are conjugates, if you do the FOIL, you get 2 times 2, 2 times root 2 with negative root 2 times 2, and root 2 times negative root 2, which is 2. Again, these two cancel each other. 4 minus 2 is just 2. And if you multiply the numerators, 2 root 2, 2 times root 2, minus root 2 times root 2, which is 2. You may ask, can I simplify more? Yes. When we see that the whole numerator is divisible by 2 and the denominator is also divisible by 2, you can divide everything by 2. And if you divide both of the top and the bottom by 2, you get root 2 minus 1 on top, and you get 1 at the bottom. The answer is root 2 minus 1. We are done.